Across Turkey, colossal hydroelectric projects are reshaping rivers, landscapes, and entire regions. In this video, we will explore two of the most ambitious undertakings currently underway. First, we will take a closer look at a massive hydroelectric dam under construction on the Colossal River in Artvin Province in the Black Sea region. Then, we will reveal how Turkey is also building what will become the largest suspension bridge in the world. But before we begin, don't forget to like the video and subscribe to our channel. Construction of this gigantic hydroelectric plant is now approaching its final stages. Unfortunately, once the project is completed, the city of Yusufeli, located about 5 miles from the dam site, will need to be submerged. Throughout history, humans have built structures to control the flow of water, primarily for agricultural purposes. However, dams constructed in the past were far more modest when compared to modern projects. Today's dams are true marvels of engineering and technology, featuring enormous concrete walls equipped with sophisticated gates and control systems, built transversely across major rivers. At the same time, the taller a dam is, the greater its water storage capacity. In the case of the Yusufeli Dam, its height will reach 886 feet, making it the tallest dam in Turkey and the 7th tallest in the world. It is designed as a concrete arch dam. Construction of the dam began on December 21, 2012. The Yusufeli Dam will be the second largest project within the extensive Colossal River Development Plan, which includes the construction of 13 dams in total. Of these, 2 are already in operation, while 2 others remain under construction. The primary purpose of the dam is hydroelectric power generation, supporting a facility with an installed capacity of 540 megawatts. The project has generated controversy due to its anticipated impact on biodiversity in the reservoir area, as well as the forced resettlement of local residents. As for the hydroelectric plant itself, it is expected to generate approximately 1.9 billion kilowatt-hours of electricity with a total capacity of 558 megawatts. This output will be sufficient to meet the energy needs of around 650,000 people. The new hydroelectric dam being built in the northeastern Turkish province of Artvin is expected to contribute more than $221 million per year to the national economy. The project was entirely designed and constructed by Turkish engineers. Located about 43 miles southwest of Artvin, the Yusufeli Dam will feature a double curvature arch design, standing 886 feet tall from its foundation and 732 feet from the lowest point of the river. The dam will also have a crest length of 1,608 feet and a width of 49 feet. In total, approximately 5.2 million cubic yards of concrete will be used. To put this into perspective, that amount of concrete would be enough to build roughly 50,000 houses. The dam crest will be at an elevation of 2,346 feet above sea level. The normal operating level of the reservoir will be 2,329 feet, the maximum level 2,336 feet, and the minimum level 2,898 feet. The reservoir area will cover about 12.7 square miles, with a total storage capacity of 2 billion cubic meters of water, of which 1 billion cubic meters will be usable volume. The dam's spillway will be a tunnel with a maximum discharge capacity of about 282,500 cubic feet per second. The power plant will feature an underground powerhouse measuring 361 feet in length, 70 feet in width, and 148 feet in height. Inside the plant, 3 vertical shaft Francis turbines will be installed, each with a capacity of 110 megawatts. In a project where approximately 8,500 cubic yards of concrete are placed daily through 3 cable lines, reservoir filling and power generation are about to begin. Final inspections of the dam are underway prior to the official start of operations. A special system was installed at the construction site to move large-scale construction equipment. With the help of a cable crane system installed from slope to slope, tons of equipment are transported through the air. When the Yusufeli Dam enters full operation, it will produce about 560 billion kilowatt-hours of electricity per year. With an installed capacity close to 109 megawatts, this output will be sufficient to supply the annual energy demand of a large city such as Antalya. With the commissioning of the Usifeli hydroelectric power plant, the country's total hydroelectric generation capacity will increase by about 2%. This dam, which can be described as a true engineering miracle, will remain as a monumental legacy, demonstrating what the Turkish people are capable of. The project was not limited to building the dam, but also included 68 miles of roads, as well as 45 tunnels, 22 bridges, and 92 culverts. The project is expected to generate $83.5 million per year for the national economy and pay for itself within 7 years. The Dardanelles Strait has always been a strategic point for Turkey. This stretch is about 75 miles long and only 2.5 miles wide at its narrowest point. It connects the Black Sea to the Mediterranean Sea and opens an important maritime route for resource-rich countries to the rest of the world. Together with the Bosphorus Strait, the Dardanelles form the natural boundary between Europe and Asia. Despite its importance, until 2022, the continents were connected only by 3 bridges and 2 tunnels, all located in Istanbul, which caused enormous congestion in both maritime and land traffic. For the first time, Turkish authorities attempted to solve the problem by planning the construction of a bridge in 1988. However, due to a series of political and economic reasons, development of the project was frozen in 1995. More than 20 years later, in 2016, the Turkish government resumed the initiative. 1 year later, the contract was awarded to a local consortium of construction companies, in partnership with 2 South Korean corporations. Construction began in September 2017. Large foundation caissons were installed at a depth of about 131 feet, with special waterproof supports. Each of them weighs up to 65,000 tons. To withstand earthquakes, they were equipped with steel structures, and special platforms made of the same material were placed on top. On each of them, the bases of the bridge towers were installed, each with a height of 1,043 feet. The 1915 Çanakkale Bridge, with a central span of approximately 6,637 feet, is a candidate for the title of the suspension bridge with the longest main span in the world. The total length of the bridge is 15,118 feet. Each of the steel cables contains 126 strands, forming the main cables of the bridge. In total, about 100,700 miles of steel wire and 296 cables, each measuring 14 to 206 feet in length, were used to form the main cables. The total length of wire used is equivalent to approximately 24,155 miles, about 4 times the circumference of the Earth. The bridge and associated highway project includes 1 suspension bridge, 2 access viaducts, 4 reinforced concrete viaducts, 6 underpasses, 38 pedestrian overpasses, 5 bridges, 43 undercrossings, 115 culverts of various sizes, 12 interchanges, including a connection to the national highway, 4 service areas, and 2 maintenance and operations centers. The 1915 Çanakkale Bridge has a total length of 12,764 feet, with a distance of 7,293 feet between the 2 main towers, and features 6 traffic lanes, 3 in each direction. This type of bridge is currently the longest in the world in its category. The bridge reduces the crossing time between the 2 shores to just 6 minutes by car, compared to the hour and a half previously required when using ferries. The structure rests on 2 foundations, each measuring 1,093 feet in length. At the same time, the height of its towers is 1,043 feet, exceeding the height of the Eiffel Tower, which stands at 984 feet. The total annual economic benefit generated will be $85 million. The underside of the bridge deck is about 230 feet above the water, allowing large ocean-going vessels to pass freely. The region where the bridge is located presents challenges such as strong winds, high seismic activity, and heavy traffic of large container ships, all of which had to be carefully considered in the design. Strong winds are always a critical factor for a long-span suspension bridge. To ensure the aerodynamic stability of the structure, a dual aerodynamic box girder system was adopted. In addition, since large container ships and cruise vessels pass beneath the bridge, the design also took into account the risk of collisions with ships. The foundations and piers of the bridge are seated on the seabed at depths of about 148 feet on the Asian coast and 121 feet on the European coast. This construction megaproject was completed in record time, in just 4 years. The total cost of the project reached €2,545,000. In the construction of the 1915 Colossal Bridge, which will for the first time directly connect the European and Asian shores of the Dardanelles, about 500 workers and 740 units of construction equipment were involved. The bridge will allow Turkey to save approximately €415,000 per year in fuel alone and through reduced emissions. According to expert estimates, the positive economic impact of the bridge on Turkish industry could reach around €5.5 billion annually. A total of 118,000 jobs will be created, and GDP will increase by about €2.4 billion. But most importantly, the 1915 Colossal Bridge will become an alternative and shorter route between Istanbul and the southeastern regions of the country. It will also enable the development of international tourism and reduce delivery times for goods from western and northwestern Turkey to these regions. Finally, the bridge will dramatically transform transportation between Asia and Europe. Trucks, tour buses, and passenger vehicles will no longer be forced to endure long queues to board ferries crossing the Dardanelles. What once required waiting hours at ports will now take just minutes, creating a faster, safer, and far more efficient connection between the two continents and permanently reshaping logistics, tourism, and daily travel in the region. Now tell us in the comments, were you impressed by these Turkish megaprojects? If you enjoyed this video, don't forget to like it, subscribe to the channel, and turn on notifications so you don't miss what's coming next. Be sure to check out our previous videos as well. They're packed with incredible engineering stories just like this one. See you next time.